This is our Unit 3, Lesson 6 video, and these are our goals. The first goal is to be able to write an inequality to model a word problem. The second goal is to be able to algebraically solve the inequality and write the answer in any form. And just to remind you, when we talk about in any form, we're talking about in inequality notation. It could be as a number line. It could be an interval notation. Okay, so being able to write it in any form that they ask us. And then number 3 is to interpret the solution in terms of the problem. So be able to answer the question that they're asking. Our steps for these word problems are exactly the same as what we've been doing. You've got to define your variable. I know a lot of you are not enjoying doing that, but it is part of creating a complete solution that somebody can read. So we need to know what the variables represent. Write an inequality, solve the inequality. For solving the inequality, find the border point, boundary point. Put it on a number line. Set up a test point, and then shade. Okay, and then make sure to answer the question. So here's example 1. The science department needs to buy new textbooks and lab kits for the science classroom. The textbooks cost $206 each, and the lab kits cost $375 each. If the science department has $9,500 to spend and purchases 30 textbooks, write and solve an inequality to determine how many lab kits they can buy. So when I read this through, I see 2 different values. I see textbooks and lab kits. So I'm going to let T equal the number of textbooks. And I'll let L equal the number of lab kits. Another reason that having your let statements is good is because it'll help you to organize your information. They tell me the lab kits are $206. So I'm going to put that on the same row. Sorry, they tell me the textbooks are 206. So that's going to go on the same row. And then the lab kits are $375. So I'm going to put that down next to the lab kits. They also tell me they purchased 30 textbooks. So the number of textbooks equals 30. The other thing that you need to keep in mind, and this is sort of an aside, to find a total cost, you have to take the number of items and multiply it by the cost per item. So if I buy 30 textbooks, that's going to be 30 times 206, or 206 times 30. If I buy L lab kits, that's going to be 375 times L. They tell me I've got $9,500 to spend. That means that I've got to stay within budget. So I am able to spend $9,500 or less. So how can we figure out how much we're spending? Well, the first thing I'm spending is I'm paying for those 30 textbooks. So I'm going to go to my calculator. I'm going to open a new page, add a calculator page, and I'm going to figure out what 30 times 206 is. And that gives me 6,180. So that's for the textbooks. If I add in the lab kits, that's going to be 375 times the number of lab kits that I buy. And I need to make sure that the amount I spend is less than or equal to $9,500. So I defined my variables. I wrote an inequality, and now I'm going to go ahead and solve it. So I'm going to start by figuring out what my boundary point is. So how many lab kits can I buy so that I spend exactly $9,500? So remember, we want to get our terms with variables on one side and any numbers without variables on the other. So 9,500 minus 6,180, 3,320. And then 375 L. To get L by itself, this is 375 times L. So I'm going to divide both sides by 375. And I get that L equals, I'm going to go ahead over in my calculator. I'm going to hit Control Divide. Oops. Okay. I'm going to type in 3,320 divided by 375. And when I hit enter, unfortunately, I get a fraction again. And this has come up for a lot of you. The way that you would change this back to a decimal is you would highlight it, hit enter to bring it down. And then if you hit control enter, it will give you a decimal approximation. So the number of lab kits I can buy is 8.85333. So that's my boundary point. So I'm going to set this up on a number line. Here's 0. This number line represents the number of lab kits. Here's 8 lab kits. Here's 9 lab kits. 8.8 is going to be about here. Okay. So I know that's my boundary point. Second thing I need to figure out is which direction do I shade? So now I'm going to figure out, I'm going to use my test point. So I'm going to test L equals 0. So if I buy 0 lab kits, will I be under my $9,500? Well, hopefully it makes sense that we will be, but let's plug it in to make sure. So 6,180 plus 375 times 0 needs to be less than or equal to 9,500. So this becomes 6,180 plus 0. And I get 6,180 is less than or equal to 9,500. And that is true. If all I buy is the books, if I buy 0 lab kits and 30 textbooks, then I know that I'm going to be under budget. So 0 makes it true. So I've got to shade this direction. However, there's a limiting factor I need to think about here. Does it make sense to buy -2 lab kits? Hopefully, you realize that that probably doesn't make sense. The fewest number of lab kits I could buy is 0. Okay. So it looks like my solution, if I could buy a partial lab kit, would be to buy 8.853 lab kits. That's the greatest number I can buy. However, there's nothing that says that we can buy a partial kit. So I'm going to assume we have to buy an entire kit. So we want to figure out how many lab kits they can buy. Well, to stay within budget, they can buy what's the greatest whole number of lab kits they could buy? 8. So I would say they can buy at most 8 lab kits. Okay. So they can buy at most 8. So again, we were able to set up our let statements. We set up our inequality. We found our border point or our boundary point. We tested a value to make sure we were shading the right direction. And then we interpreted it in the context. We knew we couldn't buy -2 lab kits. So we decided, okay, we can't buy negative numbers and there's nothing that says we can buy a partial lab kit. So to stay within budget, they can buy at most 8 lab kits. Okay, here's what I want you to do. I'm going to read through number 1 with you and show you how I would go about eliminating some answers in number 1. When you're looking at a multiple choice question, the first thing you want to look at is you want to look at your answer choices and see what is similar about them. So I notice here that my first column, all my answer choices have a 0.75 times something. In one case, it's a variable, another case, it's a number. My second column, what I'm adding to it in each case, is $1.25 times something. And then I'm comparing it to 22. And one thing that's really different here is which direction my inequality is. So let's read the problem and see if we can eliminate any answer choices. So the cost of a pack of chewing gum in a vending machine is 75 cents. The cost of a bottle of juice is 125. Julia has $22 to spend, and she must buy 7 packs of chewing gum. So if she has $22, this means she can spend $22 or less. She can't spend more than what she has. So that means whatever amount we calculate is going to have to be less than or equal to 22. So I can eliminate answer choice 1 and I can eliminate answer choice 3 without even doing anything else. The next thing is going to be a little bit of organization. So I've got gum, which is 75 cents. And I've got bottles of juice, which they tell me are B, and those are 125. I noticed there's a 7 in there. Where does that come from? Well, right here it says she buys 7 packs of chewing gum. So remember what we said before, the money times the number of items gives you the amount that you're going to spend. So if I look at my 2 answer choices remaining, I've got 0.75 times B. Well, that doesn't make sense because the bottles of juice are not 75 cents. So I think I can eliminate 2. It looks like 4 is my answer. What I'd like you to do is pause the video and very carefully read through 2 and 3 and try to use this strategy to get to the correct answer choice. Once you're done, hit play and you can check your work. Here's how I organized my answers. So I went through and organized the information, and I got answer choice 2 for both of them. Okay, moving right along. Example 2. A store sells grapes for $1.99 a pound, strawberries for $2.50 a pound, and pineapples for $2.99 each. Jonathan is $25 to buy fruit. So before I go any further, if he has $25, he's got to spend $25 or less. So I'm going to guess that my inequality is going to be something has to be less than or equal to 25. He plans to buy 2 more pounds of strawberries than grapes. He also plans to buy 2 pineapples. If X represents the number of pounds of grapes, write an inequality in one variable. So that means even though he's buying 3 different things, I should only see X in this inequality to model this scenario. So the good news is they tell me X is the number of pounds of grapes. So, and pounds is abbreviated LBS. There must be something else I know about the grapes. So if I go back up, I see they're $1.99 per pound, which means if I want to know the total that he spends on grapes, it's going to be 199 times X. Now, the next thing it says is he's going to buy strawberries. But when I look at the information on strawberries, it says he plans to buy 2 more pounds of strawberries than grapes. So if grapes are represented by X and he buys 2 more pounds of strawberries, then X plus 2 would represent the pounds of strawberries. And when I look up here and see what I know about strawberries, they're $2.50 per pound. So when I take my price times the amount that I buy, this is the expression I get. Make sure the X plus 2 is in parentheses. Okay? You've got to multiply the 250 by the entire amount of grapes, and that's represented by X plus 2. The last thing we have is pineapples. I don't need a variable for that because I know he buys 2 pineapples. And they're, what are they? $2.99 each. So that would be $2.99 times 2. So now if I wanted to know the total amount of money he would spend, this is the amount he spends on grapes, strawberries, and pineapples. So I need to add those up. And I know that needs to be less than or equal to 25 because that's all the money that he has. So the first thing it said was write an inequality in one variable that models this scenario. I did that. So I want to make sure on my Regents exam that I get the credit for that. So there's the inequality that models it. Then it says determine algebraically the maximum number of whole pounds of grapes he can buy. So now I'm going to try to find my boundary point. So 199x plus 2.5 times x plus 2 plus, I'm going to go ahead and do 299. Oops. Times 2, 598. And I'm going to see how many pounds I can buy to get exactly $25. Okay. First thing I see is parentheses, so I've got to distribute. And 2.5 times 2 is 5. Before I start moving things around, I've got to combine things that are on the same side, which means I'm not going to use opposite signs. I'm going to take 199. Remember, you can't enter an X in here. Okay, at least not if you haven't stored a value. So I'm going to take 199 plus 2.5, and that's going to give me 449. So when I add these together, I get 4.49x plus 5 and 598 is 1098. And now that I've simplified everything on the left side, I can start moving things around. So I want to get my term that has x in it alone. So I'm going to subtract 1098 from both sides. On the left side, I'll get 4.49x equals 25 minus 10.98 gives me 1402. And then the last thing I need to do to get X alone is divide by 4.49. Please remember or notice we are not dividing by 4.49x. We're just dividing by 4.49 to get the X by itself. And this I'm definitely going to do in my calculator. 14.02 divided by 4.49. And I get the X could be 3.12249. So that's where the cost is going to be equal to $25. If I buy 3.12249 pounds of grapes, I will spend exactly $25. Now, let's think a minute. Can I buy fewer than 0 pounds of grapes? I don't think so. Okay. 3.122 is between 3 and 4. It's just barely above 3. So if this many pounds of grapes is exactly 25, am I going to be able to buy more than that and stay within my budget? Probably not. So I think this is my maximum number of pounds. But again, if I do a test point, I'll test when X is 0. So if I don't buy any grapes, that's going to be 199 times 0 plus 250 times 0 plus 2 plus 598. And I want to see what that comes out to be. 199 times 0 is gone. 2.5 times 0 plus 2. So that's 2.5 times 2 plus 598. And I need this to be less than or equal to 25. 5 plus 598. That gives me 1098. Is that less than or equal to 25? Yes, it is. So I can definitely buy up to this many pounds or less, but not below 0. Now, I've got to go back up and read the question. Determine the maximum number of whole pounds. So if I look at my solution, what's the maximum, the largest number of whole pounds he can buy? That would be 3. So my answer is the maximum whole pounds of grapes he can buy is 3 pounds. Done. Okay. I want you to try this one. Okay. So pause the video and see what you can figure out here. And just as a tip, you might want to think about setting up a table for this. Okay, here's my solution. One thing that was tricky was this part right here. She saves only 3/4 of what she gets. So each week she's only going to save $72. I've got my let statements. Y is the money. X is the number of weeks. I know that she's got to save at least $580. So that's my Y value. And then this represents how much she saves from week to week. So the amount she saves has to be greater than or equal to 580. And I went ahead and I solved it algebraically. I saw that it was going to take about 6.18056 weeks. I tested 0 and saw that that would not give her enough money. So it needed to be greater than or equal to 6.18056 weeks. However, the question says the number of full weeks, the minimum number of full weeks. So the lowest whole number of weeks that's in this solution is 7. Okay, here's the last one. A lawn mowing business is starting up. They initially spend $12,000 to purchase equipment and they charge $170 per hour to mow a lawn. What is the minimum number of lawns they need to mow in order to make $10,000 profit or more? So let me start by thinking about these costs here. So when X is 0, they initially spend $12,000, which means that's going to be a negative amount that they have. If they work for 1 hour, that's going to increase the amount of money by 170. So that's going to give them negative $11,000 or negative $11,830. And then it would keep going this way. So the money, their profit is represented by the expression negative 12,000 plus 170x. And what does x represent? Well, I'm going to let x equal the number of hours that they're mowing lawns. If they want to make a profit of 10,000 or more, that means whatever they make needs to be greater than or equal to 10,000. So how do we figure out what they make or what their profit is? It's right here, negative 12,000 plus 170x. So first thing I'm going to do is solve for my boundary. How many hours do they need to work to make exactly $10,000 profit? I'm going to go ahead and add 12,000 to both sides. That's going to give me 22,000. And then to get x alone, I'm dividing just by 170. And because I anticipate this probably isn't going to be a nice number, I'm going to hit Control Enter right off the bat. So I get x is 129.412. So on a number line, 0 is going to be the minimum they can work. 129.4 is between 129 and 130 hours. So if they work exactly 129.412 hours, they are going to make exactly $10,000. Hopefully it makes sense to you that if they work above that, they're going to make more. But again, if you need, you can plug a test point in. If you plug 0 in, if they don't work any hours, this money is gone. So they're in the hole $12,000. And negative $12,000 is not greater than 10,000. So 0 hours wouldn't work. Now the question is, what is the minimum number of lawns they need to mow? This actually should say this. I'll fix this. The minimum number of hours, and we'll say whole hours, they need to work in order to make $10,000 profit. So the minimum number of whole hours that they can work is 130. Okay. And you could always add to that. They need to work a minimum of 130 hours to make a profit of $10,000 or more. Okay. So our goal in this video again was to be able to write an inequality to model a real world problem, be able to solve it and write the answer in any form and interpret the solution in terms of the problem. And we did that in pretty much every single problem in here. So it's going to be important that you read carefully, that you organize your work. There are some problems in the remainder of the packet that you can work on. Have me check them periodically as you're working. And then you'll notice that there is, if we look at this checklist, so 3.6.1, you just did. So you can check that off. 3.6.2, class notes, packet, and calculator, independent practice. Work on the remaining problems in the notes. So once you complete those and check your work, you can check that off. Then there's a chance for you to do some practice on delta math. And finally, once you feel ready, you can see me to get your checkpoint for 3.6. Whatever you don't complete in class today of these 3 things is going to need to be homework. So please make sure that you're working hard. Yeah. And let me know if you've got any questions.